Hello, my name is Teresa Stack. I'm an assistant professor with Montana Tech of the University of Montana, and today we'll be covering another ergonomic survey tool called the Brief Method, and this method has been put together by a company called Human Tech, and it's quite comprehensive, and I think you'll find it rather easy to use. So I believe it would be best if you print off or have alongside of this presentation the survey tool, the brief survey tool, as well as the example sheet that I fill out and potentially the picture of the worker that we're going to be evaluating. It seems really a lot easier if you can look at the picture when you're going through the evaluation than try to imagine what the worker was doing. So the BRIEF survey is based on the BEST technique. BRIEF stands for Baseline Risk Identification of Ergonomic Factors, which I usually call ergonomic risk factors. And BEST is the Brief Exposure Score technique. It's used, again, mostly any of these tools are used for things that are regularly foreseeable within a worker's everyday tasks. And this is a formalized observational method that looks at specific risk factors in the workplace and identifies their root cause or what's driving what I consider called driving the data. What's the worst part of the task that we're seeing and how can we possibly correct that? The reason why I find this a very useful tool, not only has it been validated by scientific research behind it, and you'll see that it looks much like Rula and Reba. But the tool combines a body score survey, so it looks at posture, force, duration, and frequency. It also looks at other physical stressors such as vibration, temperature extreme, impact, and low temperatures or high temperatures, as well as impact and soft tissue compression. It combines both the posture, frequency, and duration scores with the physical risk factor scores to come up with a job risk factor score. That is then multiplied by the exposure to come up with a job hazard score. So it not only takes a look at the posture that somebody's in, but as well as how often they're doing it within their job. So if you're looking at the tool, you'll see that step 1, you simply detail the job information. And in step 2, it's recommended that you, of course, introduce yourself to the employee. You should have a background information of what the process is, so you've already done your research. I would also highly recommend that you watch the short video, How to Conduct an Ergonomic Survey, before moving forward and trying to do this in the workplace. It's posted within this module on Moodle. After you introduce yourself, you describe why you're visiting, as well as what activities you'll be performing, so the worker is completely informed in what you'll be doing. And I try to use the word evaluation versus inspection because inspection sets up a type of mindset where people feel that they're that you're going to be the safety police. And we don't want to be the safety police here. Instead, we want to find ways to potentially improve the performance of the worker or the quality of the workplace. You let them know that you're going to conduct an interview. Watch them perform the task, hopefully from different angles, and you'll be taking notes when you're doing so. If you're allowed to, take pictures or video the process. Then you'll complete the risk assessment form and come on back with them and brainstorm areas for improvement. So there's also that feedback loop. I would recommend as well, anytime you put an intervention in place, to follow up and make sure that you didn't create or generate any new hazards. So step 3 is we collect information about the task. And you can see on the form that it's broken up in another number of subparts. So you would watch the worker work or record them working and then come back and break the job down into parts. And then you would identify the occurrence of awkward postures, long durations, high forces, and identify which parts of that task that you'd like to make a closer analysis of. This can be either because of the force, it could either be or in combination with the force and the posture being at a high exposure level, or the frequency and the duration of that task cumulatively increasing the exposure level of the job. And so this would be the survey form that Human Tech has produced. Certainly you can use your own, but it's nice to break things down into subtasks. So we're going to take a look at a crimping task, and hopefully by this point I'll have it compressed, the video small enough so you can watch the entire life cycle of this task. These are workers who are repairing high and low voltage lines. So although they're doing this for our purposes, when we evaluated it, we're doing it kind of in a laboratory or a classroom setting, but they'd also be doing this out in the field. And so they have to they have to cut the wire, clean off the edge, and then splice the wire back together again. And I'll show you some other steps in the process. The tools that the workers need for this particular task are, of course, the wire, the butt splice connector, the crimping tool, a utility knife, some shrink wrap, heat source, as well as a wire cutter. And you can watch the video and then come on back, or we can just move forward. And so I'm using this task as an example to show you how to better apply the tool. So I already broke down the steps in the process, and you can see that from watching the video. And then went back, and the steps in the process that are in bold, these would be considered the ones, these were the ones in which I thought there were considerable risk factors, but of the highest risk factors were the tasks that are underlined and bolded. And so those were the tasks in which you would choose to do your postural analysis on. So the worker retrieves the tools, provides access to the wire that needs to be spliced, and so that if they were out in the field, they would have to dig up around that if the wire was underground. They have to adjust the crimping tool to make sure that it matches the size of the wire. Then they cut the wire. They strip back the insulation on the wire, so you're exposing that conductive end. Ensure that it's clean from dirt and other contaminants. Then they'd add the shrink wrap to the sleeve, insert an end over the wire so that you're making that connection. Ensure that the crimping tool is again adjusted appropriately when you're going to splice the connector back together. Crimp the butt splice conductor using the crimping tool, which you'll see is highly manual. Rotate the wire 90 degrees. Crimp the butt splice connector again. Insert the other end of the connector into the splice. Crimp the tool again. Rotate the wire 90 degrees. Crimp the tool again, and then slide the shrink wrap over the two exposed ends of the wire. Use the heat source to shrink the shrink wrap over the wire and then store the tools. So of course, if you watch the video, it would be much more interesting than listening to me talk about it. So if we kind of go back here and we take a look at the picture, the worker here is trying to crimp the wire. So he's trying to crimp or splice two pieces of wire together before putting the shrink wrap onto the wire. And you can see the posture that he's in and imagine the high forces, as well as the likelihood for that crimping tool to slip when he is performing the task. So as we're watching the task, we would also use some interviewing techniques. The two questions there with the stars are ones that I added in above and beyond the Human Tech tool, just so you know that it's something that I've learned from experience. But you can ask, what are the biggest challenges with doing this job? With what tools and tasks are notoriously difficult to work with? What do you routinely experience discomfort as a result of doing this job? When does that occur and where? Do you have any suggestions on how to improve the job? As you all know, as practicing industrial hygienists or occupational safety and health professionals, no one knows the job better than the worker. And sometimes they're just not quite sure how to implement the solution, but by talking to them on a one-to-one level and not being the evaluator or the safety police, you can get them to open up and share their ideas with you. And then after you're done, of course, watching, I would say at least 3 times the task all the way through from different angles. You can ask, are there any parts of the job that we haven't seen? Now, as a side note, some things that I do when I conduct evaluations is that I try to sneak up on the workers and observe them before they know that I'm there, because people tend to change their job or the way that they do things. They may not necessarily change their job, but they change the way in which they approach their job and when they think they're being evaluated. And then one of my favorite questions is, if you can change 3 things about this job, money is no option, to make you more comfortable, the job more productive, or improve quality, so you go home feeling better at the end of the day, what would they be? And really listen to the worker's response. Sometimes, the sarcastic response is more money or fire the supervisor. But when you dive deeper, you may find some underlying causes there that you're able to maybe make a recommendation with. So after breaking this particular job down into steps, it was noted that steps 9, 10, 12, 13, 14, and 16 had ergonomic risk factors in them. But the most stressful part of the job was steps 10, 12, 14, and 16, and those were the actual crimping steps, where the worker is trying to marry these 2 pieces of wire together by applying a whole bunch of force using a crimping tool. And so we took that step and we broke it down even further. The master electrician is in an awkward posture, as you can see from the next picture. His torso is leaning forward. One handle of the tool is compressing on his thigh. His upper arm is approaching shoulder height, and he's putting a great amount of force on the handle. One thing we should have done there is actually measured the amount of force he was applying. He must maintain this posture for 4 times as he slices one piece of cable, and he performs each of these different splicing techniques 4 times in a 9-minute sequence, and so each step is performed for about 9 seconds. And so that's good information to break it down. How long does it take them to do the job, and how often are they in these stressful postures? And so here's a picture of the posture that we're going to evaluate. It's the posture which we felt at the time was one of the 3 most severe, and this is at the beginning of the crimping task. You can see that he has, the tool is in between his legs to hold it upright. You can see the amount of force he has to apply with his upper body, a lot of hand forces and compressive forces, not only on the hands but on the thigh. So if you want to keep this picture off to the side as we go through the rest of it, I think it'll help you understand kind of what's going on and how to evaluate the tool, or based on the solution that I put together. So now going back to the brief survey, I'm on step 5. And step 5 is when we actually use the survey form. And then we'll analyze the different body parts. You can see the hands, elbows, shoulders, neck, back, and legs for that posture that we just saw in the previous picture. That's the start of the crimping task. And we'll evaluate it for posture, force, duration, and frequency, and come up with a score. So here is what the brief survey looks like. And you can see that just like using Rula or Reba, You evaluate the hands and the wrists, the elbows, the shoulders, the neck, the back and the torso, and the legs. We evaluate them for posture, force, duration, and frequency. And we come up with a score here that's based on how many of these boxes did we check. And then we put that score down here. And we take that score, that number, and we turn it into a high, medium, or low. So if you want to go back and take a look at the picture while I explain how I scored this, it'll probably make a little bit more sense to you. So looking at the picture, or after you've watched the video, you can see that both the right and the left hands are in some slightly deviated positions. Although he has his hands relatively straight, you know that during the crimping process, he's going to bring them down and go from ulnar deviation to radial deviation. And the awkward posture is, of course, for both the right and the left hands. He's applying more than 10 pounds of force using his power grip, so I checked the force box. The duration that he is in this posture is greater than 10 seconds, and we recognize that from our time evaluation. Although the frequency is not greater than 30 minutes, so I didn't check that box. So because in step 1, I checked the right hand for posture, for force, and for duration, this score became a 3, and a 3 from down here turns into a high. We go on to the elbows. When we took a look at the elbows were not, the arms were not rotated, nor were the arms fully extended. So I really didn't consider this to be a high-risk area, and you can see that it came up with a low there. I didn't check any boxes. And now we're looking at the shoulders. You can see that the arms are raised greater than 45 degrees from looking at the picture, both the left and the right. The shoulders are actually shrugged up too slightly when he's performing this task. This is a really, it really is a severe body posture because his arms are held up away from his body. He's leaning his torso forward. His legs can be somewhat unstabilized by the tool right in between his legs. And so he is, again, using more than 10 pounds of force, downward force, when he's doing this posture for greater than 10 seconds on both sides of his body. We add our posture, our force, our duration together to, once again, come up with a 3 or a high score here for both the right and the left shoulder. And if we take a look at his neck position, it isn't truly flexed forward or extended back or twisted in any way. Remember when you're looking at those postures to evaluate them link length by link length, meaning the deviation from his shoulder to his ear is in a pretty decent posture, and therefore we scored this as being a low, no risk factors here. Now we're looking at his back, which is absolutely canted forward more than 20 degrees, so we checked our box here. We don't know how much force he was applying, but the estimation was less than 25 pounds, so I didn't check the more than 25 pounds. Here it really would have been great to bring a chattel on along with you and measure what those forces were. He's again maintaining that posture for more than 10 seconds. It gave us a score of a 2, which going back here is a low. And then for the leg score, his legs are in a fairly neutral position, so we had no score here for his legs. Now our next step, step 4, would be we would identify whether there's any other physical stressors. So was there vibration, low temperature, soft tissue compression, impact, or glove issue? And glove issue is defined as where the gloves are not helping in the process, so maybe you have bulky gloves. And I would have checked 2 of these boxes, both soft tissue compression in the hands and the thighs, as well as impact stress. When you're finally coming down, and you can see it in the video, the crimper comes together, you have some slight impact on the hands. Now, I'd have to say, here's the part of the form that I personally don't like. Vibration is listed here as a physical stressor and isn't weighted as heavily as posture and force, and we know that vibration can have significant effects on a worker's body. But it's a good technique anyways. So then the next step, step 6, is we take each body area and we put in the brief score and we check off what is the highest point of concern. So for our evaluation, we saw that the hands were a 3, the shoulders were a 3, and the back was a 2. The hands and the shoulders, the highest area of consideration was the force, the amount of force that the worker had to use, and then posture, where when we looked at the back, the highest area of concern was again the posture. And so in step 7, you tried to then tease out really what the root cause is of the awkward posture, the force, the duration, or the frequency. And the root cause is, well, because the worker has to use this crimping tool, and it's completely manual, and it causes him to be in awkward postures, which is combined with high forces as well as the compression. Step 8 is, again, we transfer our brief scores onto the table, and then we convert our brief scores to a best score. So the easiest way to do that would be to show you what it looks like. So for our hand and our wrist, we had a brief score of 3/3. 3/3 meaning 3 for the right and 3 for the left. That was the score. Sometimes the scores can differ. You can be using just one hand, and then you wouldn't have the same score there. And then for the elbows, we had nothing. For the shoulders, we had 3/3 again. For the back, a 2, and for the legs, a 0. And then you can see by using this conversion chart down here that our 3s convert to 5s and our 2s convert to 3s. So it's a way of stepping up or weighting the evaluation that you just conducted. And so I'm on step 8. And step 9 is simply adding those conversion scores together, summing up what you came up with. So we had a 10 plus a 10 is 20, plus a 3 is 23, and another 3 gives us a total body position score of 26. And we're going to need this a little bit later. Our next step is we go back to our first evaluation sheet, and we put a 2 in the box for any physical stressor that we marked, and then we put a 0 in the box for any physical stressor that we didn't mark, and that gives us a total score. So because we chose soft tissue compression and impact, we have a total stressor score of 4. So in our next step, we add our physical stressor score to our body posture score. So if you remember from previously, we had a 26 for posture, force, duration, and frequency. After we did our conversion, we add 4 to that for our physical stressor score. It gives us a total score of 30, 26 plus 4. And now we have to multiply in the time factor. So you can see that the amount of time that a worker does this per week significantly plays into what our hazard score is going to be for our job. So this worker performs this task between 4 and 19 times a week, which gives us a multiplier of 0.8. 30 times 0.8 gives us a hazard score of 24. And then again, using one last table, our hazard score came out to be a 24, and we can see that a 24 is there in that medium range. So it gave us medium priority for putting a solution in place. Now, if we had measured that they were putting more than 25 pounds of force forward, that could have significantly changed our hazard score, as well as if we watched the job a couple of times and we had a closer look at the duration in which those awkward postures were being held. So our next step is we sit down with the workers and we look at trying to evaluate why and how the job can be improved. So we had high forces, and also we had manual tools. It was supposed to be a thick wire, not a think wire, with many steps. And we had manual tools. And we could probably, by changing out the tools, reduce the force, as well as by changing out the tools, potentially increase the quality of the splice, because he is splicing by hand there. Even though he's using a crimper, he isn't using a tool that has a hydraulic press on it, which I've seen in other instances. And then the last step is just in your priority matrix to look at which intervention techniques are going to have the greatest impact and they're the easiest to implement. We may prioritize them as doing them first over tasks that have or solutions which have a low impact and are difficult to implement. And so the solution that they came up with for this particular task was this connector that they can take the wire that's going to be sliced. They put half the wire on one side and half the wire on the other side, and then they twist these 2 points here, and it splices the wire for them. So they're almost able to completely eliminate the use of that crimping tool, and in doing so, it would bring the force as well as the posture risk factors down significantly. So I think that you can see how easy it is to use the survey tool. You evaluate each body part for posture, force, duration, and frequency. You put a score down here. Your score then converts to a high, medium, and low. We look at any contributing factors. We bring that over to the next sheet, and our scores then are converted, add together, and summed. And finally, we add in a multiplier for the amount of time that the worker is exposed to those risk factors. So you can see that it's a simple tool to use. You just use observational methods, and it gives you the ability to identify not only posture and force, but as well as physical stressors. Combine that with the duration or the frequency, that the task is performed throughout their work week. I hope you have a wonderful day and you find this tool useful for you to use in the future.